Welcome to the most celebrated diamond mine in the world. It's a mine with a long history. The diamond resource was discovered in the year 1902. And then, the big thing, 2 years later, the discovery of the Cullinan diamond. 3,106 carats, about this size, and up till today the biggest diamond ever found in the world. 1947 the mine went underground. Petra Diamonds bought the mine from De Beers in 2008. It's got about 200 million carats to mine. Petra decided they into this mine for the long run and decided to invest. Invested in the C-Cut project, C-Cut phase 1, 5 billion rand investment, well worth it. And the benefit is that the rest of the ore reserves on this level can actually be established with small capital investment, because the winders and the ground handling infrastructure are already there and done in phase 1. In terms of availability of kimberlite diamond bearing ore, this mine can at least see another 50 years.
Come 2012 we decided we need to design a new plant. It's a much simpler plant, only covering 4 hectares. Much more efficient. We went for milling instead of crushing. We're running at an overall equipment effectiveness of in excess of 90%. Liberation. Now this is the way we take our diamonds. We make big rocks small and then the diamond will pop out. So we are currently running at 70% of all the material that comes in is reduced to -1 millimeter, and that is goes to the slime. So 30% is between 1 and 8 millimeter, which is then the coarser part of the tailings.
What is the cost of the plant and what will be the payback?
The cost of the plant, we've ended up around about 1.7 billion, and we expect the payback on the plant in terms of that increased efficiencies to be around about 4 years.
Prior to this project, the old Premier substation, which supplied the energy to the mine, is located in this area there, and that substation was fed by 3 Eskom 88 kV overhead lines. So with this expansion, with the drive for as we heard, the efficiency and the energy that was required for the project, we needed to relook at this entire arrangement. First thing that was required was a new bulk substation dedicated to the Cullinan mine. 88 kV substation with 2 overhead line incoming bays, 2 bus sections and 3 20 MVA power transformers. We then had to design and construct a dual circuit 88 kV overhead line, which we did with monopoles, and this was then connected to an 88 kV Eskom self-built switching type station, where the 3 existing lines were diverted through the switching station to allow the energy to flow directly into the mine's property. Starting off with the Eskom self-built, as I mentioned, it's an 88 kV self-built switching station, and again the collaboration was very important here. We worked very closely with the Eskom team and with the Cullinan team. All the designs were done by Eskom in accordance with their specifications. They put all those designs through their approval process, and they issued it to us to procure and do the erection and the installation. So that included the equipment, the layout, the civil designs, the earthing and the protection requirements, which all needed to be done in accordance with Eskom's requirements. We were involved from the early upfront infrastructure, where we built a self-built switching station for the mine. We built an 88 kV overhead line for them, and that connected into the main bulk substation on the mine property with 60 MVA worth of power capacity. That was all done and designed in-house with the assistance of Eskom on the self-built side. And we also then supplied a whole host of products through the likes of our transformer factories in South Africa. We've also supplied motor control centers, low voltage drive solutions, the medium voltage drive mill package, as well as containerized MC3Cs through Shore Controls, which is also a manufacturing business in our group. And then of course the overall installation and construction, putting all these together, the motors that we supplied, the drives, the transformers, the panels, putting them all together into a complete workable electrical solution. So Ian and I came in there and did all the cable pulling, installed cable racks, put all the equipment into position and essentially put all the pieces of the puzzle together.
So you're on surface and you're also underground. On surface, we've seen some wonderful substations. Underground, you with the C-Cut project. Tell us about the combination of the surface and underground electrical sourcing.
So I think essentially, we were involved primarily on surface. There was a portion underground for the E&I team, as well as, when it came to the MCCs that were put in there. As the C-Cut developed, we were pulling in cables and terminating, putting in lighting systems and putting in the equipment which followed the development progress of the mine. And then of course on surface it was a similar process where we were putting in the equipment, so essentially an overall solution.
Is this one of the biggest diamond projects you've been involved with?
I think certainly from a group perspective it's one of the largest, where we see multiple different group packages coming together in one project. As you mentioned, over 200 million rand worth of business for our group, so it was a very significant project. We've of course been involved in the diamond industry for some time. Mining of course is a very key market for our group, and probably will remain to be for some time. But essentially we have supplied into the diamond mining industry with all our products and services for many years.
And when I went into the milling section, I saw an enormous electric motor driving these enormous mills. Now, an electric motor, what sort of capacity are we talking about? Someone said to me this could power 100 homes.
Well, those mills are about 6.4 megawatt each in capacity. So they're driven off 3.3 kV machines. Those motors were manufactured in Brazil. So if you think of the capacity, they are quite significant, but also that particular range of motor, you would have noticed, a very compact design. If we have a look at what else is in the market, it's by far the most compact motor design that there is in the market at the moment, that can deliver that sort of capacity at that voltage level.
And then we saw transformers as well.
In South Africa we have 2 transformer manufacturing facilities. Essentially we're able to manufacture up to 45 MVA transformers, 132 kV at our operations in South Africa. But of course with our parent WEG we can manufacture much larger power transformers, excess of 400 MVA type power transformers in Brazil.
And this group offering that you've got, how appealing is that to the market?
There's definitely a trend in the market towards this, where you have a good product and you have the skills and the expertise to put all these products together into a workable solution. There's a lot of added value we can provide through this approach. It's definitely something we're pushing with our integrated solutions initiative within Zest WEG Group, is to see where we can potentially get involved in every single aspect of the project, put those pieces of equipment together into workable solutions and give the customer one single point of contact for a complete electrical product and services portfolio.